Introducing the new standard for on-demand industrial part production. Big enough for your most ambitious ideas. Made accessible for in-house manufacturing. Fuse X1. Produce full-scale production quality parts in a massive build volume. Or run production builds at over 30% packing density to manufacture thousands of end-use parts in days, not weeks. Unbeatable cost per part and productivity makes Fuse X1 cost competitive with injection molding. Expanding additive manufacturing into entirely new real. Fuse X1 is powered by a 120-watt fiber laser and our next-generation galvanometer system for fast, precise sintering. Adaptive thermal control enables unlimited packing freedom and exceptional part quality by delivering, maintaining, and sintering powder at an incredibly stable temperature. Print Intelligence uses AI-powered computer vision to isolate and prevent failures, maximizing uptime so you get great parts on time, every time. Fuse X1 installs and prints on day one, with a large touchscreen for intuitive operation, and a modular build unit that enables changeovers in 5 minutes or less. The Fuse Sift X1 processes powder with quick, clean, and easy breakout for massive back-to-back builds. From design to finished part, no dedicated operators and virtually no downtime between prints. Bring production in-house, iterate on large parts faster, and fulfill more orders at a disruptively low part cost. Manufacturing will never be the same. Formlabs Fuse X1.
Hey, I'm Matt Ewertowski, head of SLS Product here at Formlabs.
Hi, and I'm Ian Ferguson. I'm director of SLS Engineering here at Formlabs. And what have you got there, Matt?
Well, this here is a massive nylon part. This door frame part right here, as you can see, very thin, very durable, and this is printed on our new SLS printer, the Fuse X1. What do you got there?
Well, this is a Hoberman sphere. I've been designing printers here at Formlabs all the way back since the Form 1. I worked on the Fuse one, but I've never had a printer that could do this. And I've been really enjoying printing all the things I can imagine on the Fuse X1. So let's get into it. Let's talk a little bit about the Fuse X1.
Perfect. So, as everybody knows, we introduced the Fuse 1 Plus a couple years ago, back in 2020, to create SLS that was actually accessible. So you can get your awesome, high-quality, durable nylon parts all in a really, really easy experience. And because we've been delivering an experience that's both easy to buy and easy to use and extremely performant, we quickly became the leader in SLS. More than 60% of units that sell today are Fuse 1 Plus machines. And we've been very, very happy with the performance here. Our customers have gotten tons of value out of the Fuse 1 Plus. However, we continue to get a request from our customers every time we ask, what would you like to see next? People say, make it bigger. And we listened. Of course, the problem is that although big printers are available, there are a lot of pain points. There's a really high total cost per part, which comes from expensive hardware and software and service plans. Facility requirements are quite challenging to even get one of these systems in and set up. You have to put in a lot of work. There are long training times because you need to actually know how to operate these systems very well. Otherwise, you're going to run into all kinds of challenges. And that is tied into very messy and complex workflows with a lot of touch points, high maintenance burden, and so on. On top of that, the software doesn't make your life any easier. The software is often very confusing or difficult to use, and it's got infrequent updates, so you're kind of behind on the best features. And on top of that, of course, if you're paying a lot for service for an industrial equipment, you should be getting really good quality, but what we've heard from a lot of customers is there's a lot of frequent overpromising and under-delivering. So that's why we built the next generation of large format SLS printing with the Fuse X1. The Fuse X1 is the new benchmark for industrial SLS printing. You can build big with a 330 by 330 by 565 millimeter build volume and more than 30% pack density. It gets you really low part cost with production quality parts for less than 50% industry benchmarks, all in 1/2 of the space. And it's very productive with same-day large parts and 3 times the throughput of competitors. Not only that, but its a system like this is only worth as much as the reliability that it can offer, and the Fuse X1 is extremely reliable with AI-powered print intelligence and failure prevention, and it's extremely intuitive. It's easy to install and operate in 1 hour. You can start a print in 5 minutes. Now, this isn't a sales pitch. We're here in this webinar to dive deep into the ecosystem, into the product. So we're going to be going in a little bit more detail than what you've seen before. And also, remember there is a Q&A. So prep your questions, and Ian and I will be here at the end of it to run through and answer all the questions that you guys have about the X1 and the X1 ecosystem. So let's dive a little bit into these specific value props before Ian gets into the nitty-gritty here. It's big. The Fuse X1 is big. It's 7.5 times larger than the Fuse 1 Plus, so you can fit way more parts. And on top of that, it is a more powerful system with a 120-watt laser, so you can get those parts much faster. The larger build volume gives you so much more freedom with packing, and not only are you just printing more parts, you can print parts you couldn't do before on a smaller build volume. Because of that 120-watt laser on top of other speed improvements, you can get large parts in half the time. So this example fog lamp that on the Fuse 1 Plus took up the full build volume, it took about 10 hours to complete. On the Fuse X1, you can turn that around, you can lay it flat, and you can print in about 5 hours. Not only that, but after the heat up and the cool down, which are kind of buffered on either end of the print, you can pack a bunch of these in there, and in the same time as a Fuse 1 Plus, you could print 10 to 12 of these fog lamps. So you're really cranking more parts faster, getting a lot more throughput. It's also flexible. So dense and production builds can complete in about 30 hours, but most large builds are done in under 24. So yes, you can do these dense high mix builds. For example, over on the left, we've got a build where you're filling up the full build volume with small parts to take the most advantage of the packing and the refresh rate outside of the large parts you want to get done. But you can also do these high mix overnight prints. So something like this, which takes about 13 hours. Or if you're just doing huge parts, you need to get a prototype out tomorrow, great, you can get this huge door panel part that I was holding at the beginning of the webinar done next day, and you can get that ready to go. You can iterate much faster. Now, if you have the time and you are in a production environment where every minute, every gram of powder counts, you can really, really push the Fuse X1 to insanely dense levels. So this example here at 41% mass pack density with latches that are precisely placed to make sure you're using the full volume, you can get this done in such a way that you get a higher throughput than you could with any other system. But just leading on the flexibility side of things, if you really needed your parts next day, you were in a rush, you got to get these done, that packing gives you the flexibility that you can get parts out in the same amount of time as, for example, an MJF system. So same part count in roughly the same time. So this isn't just a system that's printing a ton of parts in 30 hours. This is a system that fits your needs, so you can get done what you need. And in that build volume, you can do about 4 times the parts of a competitor system, and that's a combination of the larger build volume, the much higher packing, and that lets you use the system much more efficiently. So you're getting less labor per job, fewer print flips. You don't have to have somebody there to flip the printer. You can just let it run. Now, something that's come up a lot, of course, is packing density. This is a big part of what we talk about with the productivity of the system. So let's just do a comparison. So on the left here, we have some data that HP recently shared on the fleet packing density across their MJF systems from 2024 to 2026. So I've taken this data, what I've done is I've just normalized it, and I've assumed equal contribution from each of the segments that they showed up, which I think is fairly equal when it comes to how you would think about the packing density. It's fairly generous. So let's put some landmarks on this chart. Right here, you've got the zero waste point. So above this point, is where your packing density is equal to your refresh rate, meaning that you're not generating excess powder. And this here is the recommended packing range. So I pulled this from the HP MJF handbook, and this is the right packing range to get the best part quality and mechanical properties. Now, if we move this over to the Fuse 1 Plus, this is what our distribution looks like. This is also using volumetric pack density in the same time range from 2024 to 2026. Now, I'd like to note that I personally prefer using mass packing density. Ian's going to get into why that is, but we need to be comparing apples to apples here, so volume it is today. If we overlay this with the same packing range, you can see that 33% of Fuse 1 Plus prints are above the MJF packing recommendation today. That's a significant proportion. This is not only a feature with the higher packing that is aspirational, this is something that our Fuse customers are already taking advantage of today. And it's something that is being done on a printer with a smaller build volume that is more challenging to pack efficiently. And it's also a printer that's used for more prototyping use cases. So you can see on the left side, there is a larger peak in the low packing range, but if you're using the Fuse 1 Plus for production, you are still getting so much value out of that packing density range. And if you overlay the zero waste point for the refresh rate, you can see that even with the MJF system lower packing, lower refresh rate, you're not getting an appreciably higher proportion of prints above the zero waste point because we can keep packing prints so much denser. So you're getting more parts per build. You're getting much better efficiencies with our improved thermal control. Now, if we want to do a direct comparison, let's just overlay it. We can take this plot, we can put it over here, and you can see the delta. So on our distribution, you're getting a significantly higher proportion of parts that are on that right tail. So you're getting way denser parts for a realistic proportion of prints. Now, if we're going to look at the Fuse X1, we don't have 3 years and thousands of builds of data, but we have been running these printers with customers in the field through the year. So this is a sample segment of the data, but we can already see that Fuse X1 customers are also taking advantage of that really high packing, with some pushing it further than anything we've seen before, and still getting awesome high quality parts. So hopefully this story can help you anchor yourself on what does packing density actually mean, and what are the real comparisons between the different systems that I need to keep in mind. The bottom line is that with a system like the Fuse X1, which is going to be a production workhorse, a much larger build volume, allows you to use that space much more efficiently, you're going to be able to get so much more out of your system, print more parts, and get better economics. And that's part of the story, that's part of this whole story of the lowest total cost per part. So with the Fuse X1, you're getting a cheaper hardware. You're also getting service plans, which actually get something for you. You're going to be paying a reasonable amount for extremely good service, which we're going to talk about at the end. And all in with the better packing density, the better economics, the higher throughput, the better efficiencies, you're going to be getting a much lower cost per part, which means you're going to be getting way more value out of your system. And with that, I'm going to hand it over to Ian, who's going to dive into the details.
Hi, everyone. Yeah, thanks for giving us that overview of lowest cost, how we have the lowest cost per part, Matt. I really want to talk about how we've designed this machine to be easy to operate. This has been a very important part of the Formlabs story from the very beginning, ever since we started designing printers for professionals. So I've been working, when we started with the Fuse X1, we wanted to scale up the experience you have on the Fuse 1 Plus to a larger printer, and we've done that. We've taken all the best features in terms of user experience and brought that to this larger format machine. We've also taken time to make sure that we can bring other features that you might not expect in an industrial machine. One of the most fun challenges for the engineering team, fun in air quotes here, is making sure this machine can fit through a standard US single door. The mechanical engineering team is making sure we can get this printer through in any average facility. You can actually see in this room, we wheeled it just down the hallway through this door and into this rather compact and cozy room in order to get this hooked up. Since then, we've also been making sure that it's easy to install it. Once you get it in here, there's no special facility requirements that you may not be expecting. It's easy to swap builds, and the workflow is easy and intuitive using the on-screen controls. Matt talked a lot about high pack density and the value that brings, both to throughput and the ability for you to get that low cost per part. And so how do we do that? We do that with what we call adaptive thermal control. Adaptive thermal control is the summation of a number of different features that come together to give us some of the best thermal performance of any SLS printer ever built. So the Fuse X1 has 13 different heating zones. We haven't sacrificed any heating opportunity here in order to make sure we can get a uniform surface here. We've also taken advantage of the print process developments we've had on the Fuse 1 Plus over the last 5 years. So features like surface armor that guarantee you have a good finish with no orange peel, and thermal history control that can ensure that even large dense builds perform well are included here. We've also used this thermal control in order to make sure that we have a slim 10mm powder boundary around the perimeter of our build area, and that we've done all of our print testing using that slim 10mm powder boundary. If you open preform, the build volume you see there is the build volume you can print in. We've tested it and made sure that that entire region is reliable. In addition, the thermal camera makes sure that there is no region of the print area that you can't use. No matter what you're printing and how densely you pack your build, you're going to get a consistent thermal process through the entire printing process. I also want to go and dig in a little bit to one of my pet peeves here, which is to talk about mass or volume. We're really trying to push here in terms of making sure you have the lowest cost per part here. And in order to do that, we really want to think about parts in terms of mass. And when we look at the addressable build volume, there's really two pieces to it. There's the actual build volume, and then there's also the powder around it. This is all powder that's used during the printing process and is heated and goes through its thermal cycle. So when we're thinking about refresh rate, we want to make sure that we are accounting for all of this powder. So I like to think about this as mass, because really what you're doing is you're calculating how much of your powder is going to be above or below that refresh rate. We make sure to calculate this for you, and we try to minimize that wasted powder and make it easy for you to understand if there's any powder that is excess or above that refresh rate. So we want to be able to enable you to use that whole build volume, get all of your parts printed accurately and with good thermal control, and we want to give you the tools to help you understand this. One of my favorite new features in the Fuse X1 is what we call print intelligence. We have done everything we can to make sure that the Fuse X1 is as reliable, and we believe it's as reliable and as good as any printer. But however, sometimes things can still sometimes go wrong. For anyone who has operated an SLS printer, one of the most catastrophic failure modes is what we call a drag. A part, for various reasons, may be picked up by the recoding system and dragged across the print bed. When this happens, it can damage your entire print and take the entire print offline, taking other parts with it and causing a big, messy cleanup process as well. This can be extremely disruptive to your workflows and prevents you from getting your jobs done on time. So what we've done is we use our camera and other sensors in order with some AI computer vision, and we will identify failures before they happen. When we see a failure forming, we will edit out that portion of the print before it can spiral out of control and cause a drag failure. The rest of the print job will continue unabated. Sometimes when you have dozens, hundreds, or even thousands of parts, the rest of those parts will continue just fine, and your print job will complete as normal. So this is a really great feature. It makes sure that every job completes no matter what. And so we're really working to make sure that you always have a reliable 3D printer to get your jobs done. And just to dig in and show a little bit about how this works. A little bit of issue with the video here, but this is an example of a print job where we purposely created many defects, and we have visualized it so the camera system is identifying defects throughout this entire print job and identifying and editing out jobs here. So let's keep going here. Printer is only as good as the parts it produces, so we are very focused on creating the best parts for you. Part accuracy, dimensional accuracy, has always been a focus of on our printers, and the Fuse X1 we seek to exceed what we've done in the past. So we had the Fuse 1 Plus as a benchmark here in terms of creating accurate parts, and our goal has always been to exceed that. And this is an example of one part we printed on both. This is a drone component plate, and we've taken a 3D scan of it. This is an example where both metrics and like the dimensions that are under or within 500 microns, 250 microns, 100 microns are all improved from the Fuse X1. Overall warp is reduced. This part is even more accurate on the Fuse X1. We can also print really large parts. This is a part that's too large to print on the Fuse 1 Plus and is 3D scanned. We're also making sure these parts are accurate. We're 3D scanning them and making sure that even large parts, larger than you may have had good experience with in the past, are accurate and low warp and dimensionally what you need to get your prototyping or production workflows done. We're also very interested in comparing how we're doing against other SLS 3D printers. This is the same part printed on an HP MJF printer. You can see that the dimensional accuracy of the part scanned from the Fuse X1 exceeds it on all these metrics. This is just the start though. This is a single part scan. We are working on a dimensional accuracy white paper. We're also going to go into mechanical properties. We'll be working on that over the next few months to make sure we have a really comprehensive set of data for you to analyze and use to back up your work. And we'll be releasing that around Q4 of this year. So yeah, look for that as we produce some more data on this topic. But it's a really important topic, and I know you care a lot about dimensional accuracy. Surface finish is also important. For those of you who have used the Fuse 1 Plus, you know that parts that come through the Fuse 1 Plus and through the Fuse Blast system are ready for end use, and this is true with the Fuse X1 as well. The Formlabs Nylon 12 has a pleasing, consistent gray finish that is very smooth, especially when you use it pair it with a Fuse Blast with a polishing kit. You can get that injection molded like part finish that makes these parts ready for your customer without any additional process. On other printers like an HP MJF, you may need to be using, it can sometimes produce a splotchy finish. You may need to use other post-processing techniques like dyeing, but these can add cost, time, and lead time to your parts, as well as make your process more cumbersome. So we're happy to bring the Fuse Blast and its polishing properties as well to the Fuse X1. And then I think most importantly, we've been really focused on reliability this whole time. Fuse X1 is designed for the most demanding users who need reliability. For those of you who may be concerned about Formlabs' ability to meet the needs of industrial users, I have really good news. We are already meeting the needs of some of the most demanding users in the world today. We have fleets of the Fuse 1 Plus all over the world. It is the most installed SLS 3D printer in the world. These are two examples of fleets that are running, one in Europe that's churning through about 1,600 kilos of powder a year, and on the right we have a 27 printer installation that goes through 7 metric tons a year. These are print farms that rely on a reliable printer that has great uptime and can reliably produce parts for their users. We've taken all that experience of operating these machines, the expectations of these customers, and that's always been the baseline expectation for the Fuse X1, is that these are the people we need to be able to build for. So the Fuse X1 we know is designed for these types of really strenuous industrial applications. We also have designed the Fuse X1 to last a long time. So the Fuse X1, we've tested it for a lifetime reliability, but we know that you'll be using these printers for a long time, so the printer is extremely serviceable. Almost every part down to its frame can be replaced. The years that come, you need service. The printer is designed for this as well. And I'm going to hand it back to Matt here to talk a little bit about our SLS powders.
Thanks. Thanks, Ian. That was great, digging into all the details of why this printer is so awesome. And hopefully we've gotten you guys excited to get hands-on with the Fuse X1. But of course, it's not just about the printer, it's about the parts. So you're probably wondering, what powders am I going to get? What can I print on this awesome printer? So happy to say that Nylon 12 is available at launch, with Nylon 11 coming before the end of the year. So you'll have access to great printing, really ductile and durable nylon parts. And then we'll be rolling out the rest of the portfolio with 12 glass-filled and TPU in 2027. Of course, like our other printers, there's also open material mode. So if you want to use a third-party powder, then you'll have access to that as well. And like Formlabs products, all of our printers, we're continuously working on new, better materials that we're continuing to roll out as they become available. So you can look forward to many more advancements as well in materials on the Fuse X1. Now let's talk about the end-to-end workflow. So I'm also going to go through at the end here and give you a workflow demo of how you would start a print on these systems, but let's look at it big picture. So end-to-end, fully covered by Formlabs, so you can get the equipment, you can work with preform to prep your builds, and then you can go from powder to finished part, really all within our ecosystem. So let's dive in a little bit to see what this looks like. So if you start with used powder and new powder, those get vacuum transported into a mixer with a large capacity. So vacuum transport is something that you're going to see throughout the ecosystem. It really helps make sure that you're not carrying buckets of powder around and making spills. Everything is very clean, very contained, and moves through each part of the ecosystem very, very well. So after you load that powder into the mixer, it mixes, and again, you can vacuum transport that straight into your Fuse X1. Now, after a full build is done, you're printing the full build with high pack densities, about 80 liters. Then the build gets pulled out, and it gets put into the SIFT X1. So you're going to be able to see what that looks like as well. All the builds are broken out. The powder goes through into a large storage capacity, so you're not blocked. If you're just printing on multiple printers, you can keep these moving through. And then that used powder is sifted and vacuum transported yet again, so you can start the whole cycle from the beginning. So this workflow, very straightforward, very easy to move from system to system. And if you're used to the Fuse 1 Plus, then you already kind of know how the whole thing works. It's very drop-in. So let's talk a little bit more about the Fuse SIFT X1. We're going to have a look at it at the end of the webinar slide portion as well. But if you like the Fuse 1 Plus ecosystem, you're going to love the Fuse X1 ecosystem. It's like the SIFT, but it's larger, it's better, it has high capacity, it holds 3 to 5 full builds of used powder, so you can get all of your parts out very, very quickly. We're maximizing, or we're optimizing for fastest time from cake to part. So you move the cake over, the powder falls through, and you're going to be able to get your parts very quickly. Again, powder transport system helps you move all the used powder through the ecosystem, so there's no heavy lifting, all the powder is managed. We also have integrated compressed air, which is a really nice feature. Not only do you have a lot more space to work with, you can also use this compressed air to really quickly clean off your builds, and the nice sealed chamber makes sure that you're not getting powder all over the place. You've got an integrated glove box. It keeps the workflow clean, and it's safe for any build size. And once you're done with getting your parts out, you have a nice little parts hatch, so you can move your broken out parts from the SIFT X1 to a parts carrier and keep moving through the system. So if you're thinking about the SIFT X1, just think about how fast you can get your parts out of the cake and into the next step of the process. Everything that we've designed here is trying to move that as quickly as possible. And just to touch on the mix kit, so the mix kit mixes new and used powder to the target refresh rate. As you saw before, you take used powder and new powder. You can vacuum transport into the system, or with new powder, you can also pour in directly if you would like, and that will just mix the powder and move it on to the printer. Let's touch on nitrogen a little bit. So with the Fuse X1, nitrogen is required to print, and as Ian touched on before, this is primarily because with large builds, you have much denser builds, a lot more heat building up for longer periods of time, and the nitrogen ensures that you get exceptional part quality and your powder also stays at peak condition. So we've worked really hard to keep the nitrogen requirements for this system very reasonable. So you can get a fairly straightforward nitrogen installation, and you don't have to put in a ton of work for a big build out and just run this printer. So on this printer, actually, we've got a fairly compact nitrogen system running in this small room, and everything is working just fine. So one thing that I would love to touch on is service. So as Ian mentioned, we have the largest installed fleet of SLS printers, period, in the world. And when it comes, even aside from SLS, we've got tons and tons of these SLS systems that we've been servicing for well over a decade. We know how to take care of our customers. And when it comes to the Fuse X1, we're going to have all the features that you would expect and more for an industrial system. We've got extended warranty coverage, including consumables. We've got accidental damage coverage. There's on-site commissioning for every system with a calibration report to make sure that you have confidence that your system is going to be performing to the level that you would like. There's going to be technicians on site within 2 business days for repairs for the production service plan, along with preventative maintenance, an uptime spare parts kit, and you can actually pick up the phone and talk to a real person. So this is something I love about our support. We work really hard to make sure that if you have a problem, you can get in touch with Formlabs and you'll be taken care of to get you back to printing.
Yeah, cool. Let me jump in here. I don't know if you can,
Yeah.
you can hold the clicker for me.
Sure thing.
So I wanted to just talk a little bit about some of our beta users. So I've had the pleasure of supporting some of our early beta users through their early printing process. One of my favorites right now is Radio Flyer. I think we showed this part during the keynote, but this remains one of my favorites. I'm a big fan of cycling, so it's pretty cool to see our printer used to develop a brand new bicycle. This print was done, majority of these parts were done in just one print, but the full print job took 3 prints with a lot of room for other parts to be included as well. So Radio Flyer prototypes not just bicycles, but a whole variety of products. And they've been busy hammering the Fuse X1 for months now, prototyping all manners of products. And so really happy to be supporting them and seeing the great things that they can do. We've also had the pleasure of working with Auditive and supporting them. They're a service bureau. They are on track to produce almost a metric ton of parts for customers, which is really exciting. Really happy to see the Fuse X1 producing large volumes of parts for a variety of users through their service bureau. They also have been practicing various post-processing techniques. Here's an example of them Cerakoting some of our nylon 12 parts, getting a really unique finish that certain customers need. And then the last customer I want to talk about right now, and this is an early beta user, is Tesla. Tesla has been really impressing us. They're always intense over there in their manufacturing, and their 3D printing team is no exception. What we've seen out of them is remarkable. They've pushed this printer to levels that we haven't even pushed it internally. So they currently have the record for most pack jobs. They've produced a job with 49% mass packing density, 17.9 kilos of parts printed in 33 hours. I mean, truly a remarkable amount of parts in a single print job. Really impressed with that print job. They've also done other jobs that have pre-printed just shy of 5,000 parts in a build, small fixture parts, and they're like printing them by the barrel. So pretty blown away by what they're doing over there, and really impressed with how they're pushing the Fuse X1. It's unlocking a completely new way of them of using 3D printing and supporting their manufacturing lines. So really excited about our beta users. They've been pushing our printers, and this is part of the sort of recipe for how we're bringing such a product like this to market, and making sure it meets all of our performance, reliability, and other targets that we know you need to be successful. So we're really excited about the performance with these beta sites.
Great.
Yeah.
So this all comes together to deliver an extraordinary SLS printer. We're both so proud of the work that we've done. We're very excited for you guys to get access to this and to just continue printing parts like our customers in the field already are. The printer, as you know, it starts at $85,000. It's extraordinarily affordable for an industrial SLS system. We've printed more than 30,000 customer parts already in the field, and new deliveries will begin in Q4 of this year. So we're going to go from here to talk a little bit more about the workflow.
Yep.
We're going to dive through and explore how it is that you actually start a print. How do you go between the ecosystem components? Quick reminder that this is a Q&A. So as you've been going through, you've been sending your questions. Please continue that.
Hit us with your best shot.
Yeah, absolutely.
Excited to answer some questions.
Here.
Yeah.
Okay, great. So I'm going to drop the clicker, and we can move over here to actually show off the Fuse X1. So over here, we're going to run through how you would actually start a build and just kind of zoom in a little bit on different components of the system. So just like the Fuse 1 Plus and our other systems, you've got an awesome clean UI right here. I'm going to start a print. I'm going to be interacting primarily through here. So over here, you've got your build status, including your hopper and your build chamber status. And over here, you've also got the live view camera, so you can see what's going on inside as it's printing, just to check in at any point to see what's going on with your printer. And of course, if I want to start a print, then you've got your queue and your history right over here. So you can just start it through there. And we've got really, really easy maintenance notifications, so you can see exactly what needs to be done and when. So you can be making sure that your printer is in tip-top shape. You don't have to be tracking this on sheets. And of course, you've got all of your other settings for various routines and so on as well through the settings window. So let's actually look at how you would start a print. So over here, I just slide this over, and I get to see the interior of the printer. So this is very straightforward. If this is a full build, just kind of grab this and pull it out. And now this build would be ready to move on through the into the SIFT X1. And then to actually get this restarted, all you would have to do is move the recoder over to the center here with the built-in controls, and you just clean the recoder, just give it a quick wipe. And then if you've got a lot of debris buildup from multiple prints, then you can give it a vacuum. And for every print, inter-job maintenance, that's basically it. You're ready to go. So let's then start with a clean build chamber. You take this guy and roll it in, like so. And you're pretty much, at this point, ready to start. So we'll close the door, and we would go into our queue, and we would just start the job. Now, once you hit print, then the preheat routine starts. And at that point, it's going to take about 69 minutes for the printer to get ready to start lasing. And in that time, the printer can be filled with powder. So big builds require a lot of powder. As you can see here, this is our powder hopper. It's got a large 105-liter capacity. And if you don't like looking at the lines, you can look right here to see exactly how much powder you've got. As you can see, the UI is indicating less than 70 liters. It's correct. But if your hopper needs to be filled up while it's preheating, we do that with the vacuum transport systems. So up here, we have a conveyor system. This would be connected on the other side to your mixing system. And you would just start the conveyor, and it will dump powder into the hopper. Within the time required, there's plenty of time to fill up the hopper. You can just let it go, and then when it's done, you'll have powder start to recoat and begin the lasing process. So from there, the whole print will proceed. At this point, I just kind of like let it go. I just walk away, I come back tomorrow, and my print is ready. So let's look at what I do with a full build. So I would pull out the build chamber over here, and I would roll it over to the SIFT X1. So the SIFT X1, as you saw in the presentation, it is a fairly large breakout system. Everything here is designed to go as fast as possible, so you spend as little time breaking out parts as possible. It's a sealed system, so I just bring this down, I close it, and it's got nice sealed gaskets everywhere to make sure that powder is contained. If I come over here, the way that you get this to work is just like the SIFT, you extrude the build volume straight up, and then you use the gloves to knock the build over this way. This is a really nice large grate and a really large storage area underneath. So you can get 3 to 4 builds worth of powder down underneath here. So if you have multiple Fuse X1s, you're just extruding your builds up, knocking them over, getting your parts out, and you can keep going without being interrupted. To make things very easy for you, we've also got the vacuum hose over here just to clean up your work area. And then we've also got a compressed air gun. So if you need to clean your parts really quickly, you can just pull that out and start blasting off the loose powder. Remember with SLS, at this stage, you don't need to get the parts to be completely clean. This is just about getting all of the powder off of your parts to the degree that you can start the cleaning process. So once the powder is recovered here, the powder actually comes through into the storage area down here. And you can't see this through the machine, of course, but you've got a sifter right over here. So that powder is auger fed to the sifter, and it's fed at the precise rate that you need to make sure that the powder is not backing up, so you're getting the fastest, most efficient sifting possible. So going back to the parts, if I'm over here, the powder's falling through, it could be getting sifted and sent out, and I would just take my parts through this part hatch on the side. Makes it really, really easy to take it out and just put it into our parts carrier over here. So I got my part right over here. Now, before we finish the part workflow, let's take a step back to the powder. What happens with the powder? Down here, we've got a connector for the vacuum transport system. So yet again, vacuum transport connected from the SIFT X1 to the mixer. That powder will go into the mixer. It will be mixed. It takes about 20 minutes to mix a full batch. And then it'll be, yet again, vacuum transported over to the printer. So what do I do with my part? The powder's taken care of. So this is a little bit cleaner than what you would get out of the build, but that's because it's already gone through a blasting step. And in classic Formlabs fashion, we've got you covered from the beginning all the way to the end with post-processing in the Fuse Blast. As Ian mentioned, we've brought the Fuse Blast polishing system to the Fuse Blast so you can get these really awesome, high-quality finished parts that you can just take straight out of the build and put them directly into your end use without having to dye, without having to adjust. So one thing that you'll note here is that the Fuse Blast now has a larger blasting basket for even larger parts and higher, larger builds. So you can be getting all of your parts through end to end. You click start, and then when you come back in 15, 20 minutes, you can pull your parts out and they're ready to go. So that's pretty much the full end-to-end for a part in the Fuse X1. It goes from powder in the printer, the sintered parts, through the Sift X1, and the parts then go to your blaster. Well, the powder is all managed with really nice pneumatic transport moving between the steps, so it's clean, it's contained, and you can get to working on making things and not managing powder. So thanks a lot for hanging out with me as I went through this workflow demo. From here, I think we're going to be able to open up Q&A. So let's hop over here and see what you guys have been putting into the stream.
Yeah. Okay, hi, yeah, welcome back. So yeah, excited to get into some Q&A. Thanks for showing us the workflow, Matt, and yeah, showing off all the different pieces of hardware we have. It takes a lot of different pieces to bring a 3D printer to life and support you guys. So we're going to dive right in here. There's been a bunch of questions that have been asked on the chat. So we're going to try to get through as many as possible, and we'll dive right in. So I'm going to take the first one right off the top, which is how does increased packing density affect print quality and thermal consistency across the build volume? So this is what we've worked on a lot. What we have here, I'm going to pull up one of our favorite demos, which is this was a build volume full of latches printed. So this was filled from top to bottom, and the consistency has been really good. This is quite a challenging print in the sense that you need to have really good thermal control in order to have a part that's printed in the center of your build volume be as similar as possible to one that is all the way in the corner or on the edge. So we're really proud of the ability to print such a challenging part like this, and this is quite heavy. So I'm going to put this down. I'll take a chance to also talk about what happens if you don't control this well. So we know what happens. This is an example of a Fuse X1 latch, and these are two parts printed on a HP multi-jet fusion. If you pack too densely on a printer not really designed for this, what you're going to see is artifacts like yellowing and poor surface finish. And so what we really want to do is make sure that no matter where you print your part, you're going to get a consistent surface finish, a good part. This also is partly affected by using nitrogen. Nitrogen prevents yellowing and other oxidation, so we make sure that one of the reasons why the Fuse X1 uses nitrogen is to enable these really high pack density prints and keep the powder in as good a high performance state as possible through the entire print job. So these ingredients all come together to give us like a really consistent thermal process that we're quite proud of.
Great. I can take the next one. I guess I got an easy one here, but how long is the cool down time for a full build chamber? This one's pretty straightforward. It does depend on how much parts you've packed in here, because more thermal mass means it takes longer to cool. But as a good rule of thumb, it's usually between 1 to 1.5 times the print time. So if you're doing something that's like extremely dense, then it'd be 1.5x. But generally, when you go down to the lower pack densities, it's 0.75. So like you can clean and cool very quickly. Yeah, and we calculate this in preform. So if you're curious what this looks like, you can download preform today, pack a job, and it will break out the full print time and the different segments of print time, so you can see what is the printing time, what is the cool down time, preheat, etc. So we want to make sure that's as transparent as possible. And we know users will do all the different sorts of different things. Some people will pull their jobs faster. Some people will, wait to make sure they're really good. There are various trade-offs there. They're very similar to all other SLS 3D printers
in terms of what you're going to get if you try to cut some corners or take your time. Cool. Yeah. Does
maybe if we talk about print intelligence,
yeah.
that's a good
yeah,
question.
print intelligence. Yeah. So print intelligence will send you an alert that a part has been skipped. So print intelligence is to be open is a new feature. We've been focused on making sure it has the ability to keep your parts, your print running and reliable. And there are a lot of different pieces of information customers are already asking for, and also maybe settings to tweak about print intelligence. Should it just edit out a part, piece of a part, edit out a whole part, cancel a job instead? These are all different features. So we're working on building out sort of like the UX feature set around print intelligence over the coming months. The intention is to be able to make sure you know what has failed. Maybe potentially give you a live alert if in the future. So these are our features that we're going to be working on. Our first priority was to make sure we have a reliable feature that accomplishes the goal of keep increasing printer reliability. But these are software features that we expect to keep working on and iterating on, like we do on all of our products, to give you the feature set you need to do your job. So.
Great. The next question, fairly straightforward. Is there a way to make sure that the data on the X1 is secure? Can I remove Wi-Fi? Yeah, absolutely. So the Fuse X1 doesn't come with, out of the box, you need to add a Wi-Fi dongle, which comes with the printer to enable Wi-Fi. So it's not connected by default. If you want to keep it off, you can keep it off. You can run the printer without having to connect it to a network.
Want to dive into some of the materials?
Yeah, let's dive into materials here. Quick question here on will there be bigger PA12 packages than the 10 kg? Yeah, so we know that when you're going to be printing a lot of powder, you might want to have a little bit more flexibility in the packaging format. And we are working on bringing better and larger packaging formats. It's just a question of the right balance of like passing along all of the appropriate cost savings and making sure that we can get this in a format which is really easy to use with the ecosystem, but it's definitely something that we're keeping in mind here.
We'll talk about, can do open architecture. So so is it an open architecture? So what we provide is what we call open material mode. So you can unlock your printer so that you can print any powder on it. Preform exposes a full material settings editor so that you can tweak and run the printer as you need to run any material. You can also use that the print settings editor to tweak your own settings for Formlabs materials as well. You don't need to be locked into just Formlabs powders. If you look into open material mode, that's basic. It's now a feature that's across our entire product line, not just on the Fuse X1, and can enable third-party materials on our printers.
Great. Let's see.
What are the colors?
Yeah, there are a couple questions about what other powders we're going to be bringing to the platform. We can't talk about our roadmap, unfortunately, except for the things that we've already publicly announced. But you can expect there's going to be a lot more powders coming to the system over time, and we're going to continue improving the materials that we've already got on there.
Yeah.
There we go.
Yeah. Well, I'll just add, we've worked really hard to make the Fuse X1 as thermally capable as possible, which is kind of the main unlock for different materials. So this has always been, we've been trying to make a platform that will enable us to continue to release new materials over time. And we've learned a lot since Fuse 1 Plus about what we need to achieve there in order to enable these other materials. And so looking forward to what's going to come down the pipe there.
Absolutely. We've got one here about accessories. So it's great to see that people are already thinking about how many SIFs do I need to build out a massive fleet of my X1s. So the question is, what would you recommend the ratio be for Fuse Blast and SIF machines versus Fuse X1 printers? So the answer here is that it does depend somewhat on what kind of prints you're running. The real bottleneck on the SIFT to printer ratio is just how long it takes you to break the parts out. So what we see is that for a typical size build with typical densities, you can break it out pretty quickly, around 20 minutes or so, especially using the compressed air gun can make that move quite quickly. Now, if you're going to be doing extremely dense builds, extremely large builds, and you need to take a little bit more time, for example, if you have features that you need to get in there and clear out more manually, then you could budget up to an hour, for example, on a massive build. So that's really the thing to keep in mind is for the example of if I was running just, packed a bunch of low density builds or like typical builds up to like very high density builds, depending what I'm doing, it could be anywhere from like 16 printers to 8 printers served by the SIFT-X1. That said, it also comes down to your labor availability. So if you've got somebody full-time to break these out, then great. But if you're more of a proto shop, then you could be running 4 printers off of a SIFT-X1 without any problem.
Yeah, and then there's also, should we also talk about Blast? Yeah. Blast is sometimes can take more time in terms of not necessarily hands-on time, but processing time than SIFT. Well, you can get by with a single blast for a Fuse X1 if you're trying to have a really high throughput. We do see that sometimes there's a benefit to having a second blast. An entire build does not fit into. You can pour an entire build into a blast basket, but we see much better performance, both blasting cleanliness and throughput, splitting up a large build. Most large builds will split up into two runs. Sometimes we will split it up into 3. We run internally on our main test fleet. We have 3 blasts running for a large number of printers. So we're operating them all day to run all of our Fuse X1s in-house. So it's kind of it's a little bit about what workflow is going to work for you. If you're okay with this sort of more serial process, or if you want to parallelize it. Yeah.
Great. Let's see. So there's a quick question about vacuum conveyor. For a vacuum conveyor comes standard with the Fuse X1 as well as the SIFT X1. So you don't need to add an additional vacuum conveyor to run this as a basic ecosystem. That said, you can add an additional vacuum conveyor if you would like, specifically if you are looking to store a large amount of powder. For example, if you're running enough printers that you'd rather just dump the powder out of the SIFT X1 and then store it and then dump it over to the printers based on your schedule, then you can absolutely do that and just have a separate conveyor from a different source. So you can add more conveyors to the system if necessary.
I expect many different users to have, if you have a single printer setup, I think it'll look a lot like what Matt showed in the workflow slides and what we see here. But if you have multiple printers or, for some reason you have a different environment, I expect, we want to make sure you have the tools available to build the workflow that works for you. Maybe can build, should we talk about cleaning?
Yeah, I mean.
Cleaning the printer after a print. Using the Fuse 1, yeah.
This is a great one.
Yeah, so, one of the nicest things, so the Fuse X1, we've really designed it for really low maintenance. It really does take less than 5 minutes to turn a printer over and get it ready for the next print. As Matt talked about, you have to clean the roller, and you just have to clean up any extra debris inside the printer. One benefit of building a bigger printer is actually easier to work inside. If you haven't noticed, we made what some people would consider a comically large door. It's the door is large, but that's on purpose. You have full access to the whole printer. You can get all the way from end to end. This is really to make servicing this machine as easy as possible. We don't want it to, we want to make sure any nook and cranny that you feel like you need to clean, you can get in there without any pain. In general, you need to just focus on cleaning up the print area, but many users I know will probably want to sort of deep clean this area between print jobs, and so that process is pretty easy and should just take you should be done in under a few minutes. It's really quick. Big door enables you to get in there, which is.
It definitely makes your life a lot easier. The specific question here was, is it easier to clean out a Fuse X1 than it is a Fuse 1 Plus? And yeah, we think
I think so. Yeah. We've also worked in other maintenance. We've made, there are other pieces of the Fuse 1 maintenance routine that we've improved on the Fuse X1. Items like the IR sensor and laser window. These are both purged during the printing process and are kept clean very consistently. So there is a maintenance routine on them to inspect them, but we expect them to stay clean through most print jobs with needing no maintenance, which is a big step forward as well. There are some additional air filters to go and maintain on a semi-regular cadence to keep those systems operating, but we're keeping the printer in its top operating condition between prints with very little maintenance.
Great. There's one more question here about will Print Intelligence be backported to Fuse 1? I think Print Intelligence, obviously, extremely powerful feature, and the largest installation we have right now is the Fuse 1 fleet. So we would love to be able to bring that back to the Fuse 1. That said, there are also hardware advancements on the Fuse X1 which have made this possible. So it would be a, we are looking into it. However, there's a lot of work required to tune something like this around different hardware.
Yeah, no promises, but we are, it has a camera, so. So
it doesn't have the IR camera, unfortunately.
Yeah, it doesn't have the IR camera, so we're looking at it. We'd love to give you a good update here.
Yeah.
When we get to it.
Great. I think we've largely run through the queue here. So I guess we're pretty much wrapped here.
Yeah. So Matt, thanks for showing us the Fuse X1 today.
Yeah, thanks a lot. And I get to go and talk about this all the time. I'm really glad that we managed to get Ian out here to help deep dive into everything about the printer. That makes it awesome.
If you have any more questions, drop them in the chat or in the comment section, and we can get back to you. And
of course, contact sales or a reseller for more information. We've hopefully given you a much better picture here of the Fuse X1 and the X1 ecosystem and everything you can expect to come with this printer. Of course, I know you guys will have more questions, and we are ready and waiting to hear them from you and to answer. So get in touch with Formlabs sales or your reseller, and we'll get back to you.
Yeah. Thanks, Matt.